In Module 3.1, another property of limits that we established, it was the property number 7, told us that the limit as x approaches c of f of x divided by g of x equals the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. So we could take this limit, apply it to the numerator and denominator separately, as long as this limit didn't equal 0. So again, we want to be clear that that approach does not work for differentiating the quotient of two functions. So even though it works for taking the limit of the quotient of two functions, when we get to differentiating functions, we can't simply differentiate the function on top and the function on bottom. So another way to say that in notation would be to say that the derivative of f of x over g of x is absolutely not equal to the derivative of f over the derivative of g. So again, this is one of those common mistakes people will make. However you go about making that clear in your head, we just want to make sure that this is something that we avoid. These two statements are not equal to each other. So instead, whenever we encounter the quotient of two functions, so for instance, if we have some function y equals f of x over g of x, then to take the derivative of that function y, we're going to start off with something that looks similar to what we wrote out for the product rule. So the first function times the second function. In this case, it's going to be minus the first function times the second function. So far very similar to the product rule, except that this sign changed to a negative. In the first term, we'll take the derivative of the first function. And then in the second term, we'll be taking the derivative of the second function. Let me rewrite that first part just a little bit more clearly. So that should be f prime of x. So first term, derivative of the first function. Second term, derivative of the second function. So that's matching up exactly with the product rule, except we're subtracting. And the other difference is that we're going to divide by g of x squared. So whatever function was originally in the denominator of our derivative is going to be that original function squared.